The Nevada test site is a 3,561 square kilometer area in the Mojave Desert that was used for U.S. government nuclear testing from 1951 to 1992. Nuclear tests, including atmospheric, underground, and safety tests using plutonium-239, were all conducted. Atmospheric tests were conducted primarily before 1960, and in 1963, the Partial Test Ban Treaty banned atmospheric nuclear testing. However, underground nuclear testing continued until 1992. By the time the atmospheric testing ban was put in place, 12 billion curies of radiation had already been released, which is the equivalent of 50 Chernobyl disasters. Despite precautions, the 41 years of testing were riddled with several accidents. On April 25, 1953, a 43-kiloton atomic device named Simon was detonated 300 feet above the ground. The result was a 40,000-foot mushroom cloud of radioactive debris, which was caught by wind currents and carried all the way to New England. Above Albany and Troy, New York, the radioactive material mixed with a thunderstorm, and a rainout occurred over the cities. On December 18, 1970, a 10-kiloton device dubbed Bainbury was detonated 900 feet below the ground, but the protective casing on the device cracked. A 7,000-foot mushroom cloud resulted when the radioactive debris blew through the surface of the Mojave Desert. 86 workers were exposed to the radiation, and 2 died 4 years later from leukemia. The radiation was carried as far as Canada and the Gulf of Mexico. Numerous other disasters also occurred, and many other states were exposed to radiation. Surface effects such as collapse sinks, craters, and fractures resulted from the repeated detonation of nuclear devices below the surface. Collapse sinks have distinct radial fractures that extend from their edges, and may have interior sinks from post-detonation collapse. Furthermore, waste from the tests and the industrial sites constructed to support testing has leaked onto the desert, and radioactive waste was leaked from at least 433 of the more than 800 tests conducted. Both the physical and chemical damage has an impact on the wildlife of the Mojave Desert. In addition to impacting wildlife, water, soil, and atmospheric pollution affects the people in the surrounding areas. Aquifer contamination resulted from at least 200 tests that were conducted in proximity to the water table. Radionuclides, which are radioactive isotopes, have contaminated an estimated 1 trillion gallons of aquifer water. One of these radionuclides is tritium, which is a modified form of hydrogen and is carried well in water. Furthermore, tritium is harmful when it is ingested and decays inside the body, producing beta rays. Much of the contaminated aquifer water will be ingested when it reaches towns. The water from the Mojave test sites can flow at a rate as high as 2,000 feet annually, which means it will reach Nevada towns surrounding the test sites before the radionuclides are harmless. The plutonium-239 safety tests, in which pure plutonium was released, have led to atmospheric levels of plutonium 3.8 times higher than is normal for certain areas of the Nevada test site, and there are several known radioactive hotspots in the Nevada test site where the soil is highly radioactive. Furthermore, these areas will remain dangerous to both humans and animals for 240,000 years and are constantly being stirred up by wind and other eroding factors. The soil in the Nevada test site is also polluted with heavy metals, oil, and depleted uranium from the industrial sites. All of these materials are detrimental to the native plants and animals. The Mojave Desert is both a hot and cold desert. There are 1,200 known invertebrate species, 339 known vertebrate species, and 750 known vascular plant species native to the area. 267 of the vertebrate species and 44 of the vascular plants are considered sensitive and are protected under the Nevada Natural Heritage Program's Animal and Plant At-Risk Tracking List. Furthermore, 236 bird species in the Nevada test site are protected under the Migratory Bird Act. Of particular concern is the desert tortoise, which is also considered threatened by the U.S. Federal Endangered Species Act. 4,000 curies of radiation per square kilometer can cause complete plant death, and doses much lower cause problems in plant development. 2,000 curies per square kilometer are known to decrease birth rates in many birds and mammals. Using the estimated 12 billion curies of radiation released between 1951 and 1963, The distribution of radiation over the entire Nevada test site is over 3 million curies per square kilometer. While some of this radiation was dispersed, it is likely that the testing has severely harmed the desert ecosystems. Ionizing radiation also has severe effects on the human body. Radiation can produce free radicals and break chemical bonds, which are often reformed incorrectly. Cells can fix radiation damage at low levels, but cell death occurs too rapidly at high levels. Short-term effects include nausea, fatigue, and death. Long-term effects include cancer, cataracts, and tissue failure, and may not show up for 10 to 15 years after exposure. The rate at which cells divide also affects the extent to which radiation is harmful. Cells that divide rapidly are more likely to experience harm, which means that embryos are particularly at risk. Radiation from the Simon and Bainbury accidents, as well as the plutonium-239 tests, affected the surrounding areas, such as Las Vegas, Nevada, and St. George, Utah, as well as areas across the country, such as New York. The people most directly affected were the downwinders, who lived in the least populated areas, and were therefore sacrificed. Officials would wait until the wind patterns would blow radiation to areas of low population, so as to harm the least amount of people. These people were often farmers and so lost many crops and livestock, as well as suffered outbreaks of radiation-induced diseases such as leukemia and other cancers. It is challenging for the government to fix the mistakes of the Nevada test site nuclear testing. While contamination can be removed from soil, it is impossible to remove the contamination from the aquifer water. Officials are regularly testing and monitoring flow rates so as to notify people if water is unsafe to drink. Furthermore, the industrial sites that contain nuclear waste, waste lagoons, and trash are being reclaimed in several streamlined processes that aim to restore the area to its natural beauty. The Radiation Exposure Compensation Act is a $100 million trust fund that aims to compensate victims of radiation exposure and their relatives, such as the farmers who suffered such monetary and personal losses.